Today we're going to solve rational equations, which is simply an equation with rational numbers in it. And there will be a variable somewhere in the rational expressions. Let's look at the least common denominator of this particular problem. If you are not sure what the least common denominator is, you can always multiply the two denominators, and that can create a least common denominator. So for this one, the least common denominator is 12x. If we would have multiplied it, we could have used 24x, and it still would work out. We would just have to reduce in the end. In this case, if we know our factors, then we know that 12 is our least common denominator, or we could have figured it using prime factorization. Let's think about the least common denominator of this particular set of rational expressions. X to the fifth power includes x, x to the third, could include x squared, could include x to the fourth power, and of course it includes x to the fifth. So x to the fifth power is the least common denominator for this set of rational expressions. And let's look at this. We have to remember that this is one set. This goes together. And then we have an x, and then we have a 6. So what we're going to do is we're actually going to multiply these together like I talked about earlier in order to form the common denominator. So you can put it like this: 6x times x minus 3. So when we're looking at rational equations, it's an equation containing rational expressions. Whenever we were doing rational expressions earlier, we realized that we can multiply everything by the least common denominator, and what we can do, that will actually help us get rid of our denominators. So for 7 and 3, our common denominator is going to be 21. So what we do is we're going to multiply both fractions by 21. And then this will actually reduce to 1. And this will reduce to 3. This will reduce to 1. And this will reduce to 7. And we are left with 3 times x minus 7 minus 7 times x plus 2 equals 21. Remember, whatever we do on one side of the equation, we have to do on the other side of the equation. So what do we do with that? We need to figure out what to do with that. The first step in this particular problem, we have parentheses. We need to follow our order of operations. We have parentheses, so we can distribute our numbers to the parentheses. And then we can combine like terms. And we're left with negative 4x minus 35 equals 21. Now we solve just like we would any other equation. We add 35 on both sides, and then we divide by negative 4, and that gives us x equals 14. Let's look at another example. Whenever we're thinking about a common denominator, we need to think about the common denominator all the way through the equation, because we want to get rid of our denominators all the way through the equation. In this case, we have a 12, a 3, and a 2, and we also have some x's. So I believe that 12x is going to be our common denominator. So we're going to multiply everything by 12x, and that's going to cause this to reduce, and this to reduce, along with, of course, 12x and 12x. So let's see what that looks like after we reduce and do our multiplication. So now we're left with 6 plus 5x equals negative 4. This is just a typical equation that we're used to already. So we're going to subtract our 6 on both sides. We have 5x equals negative 10. And then we're going to divide by 5, and we have x equals 2. When you multiply by a variable expression to clear the denominators, the new equation may introduce solutions for which the original equation was undefined. So there may be times when the original equation didn't look like it could be solved, but after you clear the denominators, it really can be solved. And you have to always check your solution, because there will be some numbers that you get as a solution that do not work in the original problem, and it will not work out. We have seen that over and over, where we get an answer but it doesn't work, so there is no solution. Let's look at this one. Our common denominator is going to be x plus 1 times x minus 6. So when we multiply all of that across and we do our reducing, we end up with 5 times x minus 6 equals negative 2 times x plus 1. We can distribute and start working on getting our x's on one side and our numbers on the other side. And we're going to go ahead and add our 30. 7x equals 28. When we divide, we get x equals 4. And whenever we put this back into the original equation, we're not going to take the time to do it right now, but it does check out. Okay, so here we have 10 x minus 10x and x squared minus 10x. Our common denominator is going to be x times x minus 10. So whenever we go ahead and multiply all of that, we end up with this problem here. We then distribute and we combine like terms. We have a quadratic equation now. If we go ahead and put everything on the same side, because we have this x squared, it's easiest to solve this in a quadratic equation form. If we go ahead and factor that out, we get x minus 10 times x minus 4. So our answers are going to turn out to be x equals 10 or x equals 4. Whenever we look at the original equation, 10 makes the denominator equal 0, and the denominator cannot equal 0, so 10 is not a solution. So 4 is our only solution for this problem. This is where the check is really important. Okay, so we have 3 plus n over 5 plus n equals 6 over 7. Our common denominator is going to be 7 times 5 plus n. And when we multiply those out, we can go ahead and do some reduction. And we end up with 7 times 3 plus n equals 6 times 5 plus n. We're going to distribute our numbers and combine like terms. When we combine everything and we solve it, we get n equals 9. Whenever we put 9 back into the original problem, it works out. Go ahead and get started on your homework, number 2 through 30 even.